The final video, or the final topic that we're going to talk about in function redux is function decorators. Now this is a pretty cool feature that Python has. Now essentially what a function decorator is it's a little @ sign that we can put on top of a function that changes its behavior. So let's say I write a function def f of x return x squared. Now if I've already defined a function like derivative function, then that function can be a decorator if it takes on a few different properties. First of all, the decorator has to take in a single function as an argument. Here we take in f. It then has to return a function as the return value. Here we return g. The function that it returns has to take in the same number of arguments that f takes in. So in this situation, f of x takes in x, so g of x also takes in one variable x. So derivative function is a candidate to be a function decorator. So all I do is type in @ and then the name of the function. So now f of x has been decorated with the derivative function. So now if I try to print out f of 5, so f of 5 is 5 squared, which is 25. However, so we would expect it to print out 25. However, I've decorated it with the derivative function, which means that now it'll actually print out the derivative of f, which is 2 times x, which should be 10. So it should print out about 10. And here we see it prints out about 10. So let's see why that actually happened. Now, when you decorate it with a decorator function, what Python does under the hood is it takes your function, f. It then passes it into the decorator. So it puts f into the derivative function, and then whatever the decorator returns, whenever you use f, it'll actually be using whatever the decorator returns. So when I call f, it's actually using derivative function of f. So f of 5 is really using whatever g was created when derivative function is called on f. So just to show another example, let's say that I wanted to write a function def add 5. It takes in f and makes a new function g, takes in x, and it returns f of x plus 5. Then I return g. So this is again a decorator function for a function which takes in one variable. So I'm going to define f of x to be return x squared. So normally if I print out f of 5, I get 25, no problem. However, if I decorate this with add 5, it'll basically now take f, pass it into add 5, and it'll return me a g where it calls f of x plus 5. So now when I call f of 5, it should be 25 plus 5, which is 30, as we expected. In this way, we basically can decorate functions and do very powerful things. You don't use them often, but you do use them enough that it's really good to know about.